Okay, hi everyone. For those that don't know me, I'm Mike Nakimovich. I'm an Android engineer at the New York Times, and I'm the most recent Android GDE as well, so I'm still super proud of myself and telling everyone about that. So what I'm going to do today is kind of break up this talk into two parts. The first thing I want to talk about is a library that we just open sourced at the New York Times. It's our first Android library that we actually open sourced. And the second part of my talk, I'll go into how to open source a library. Now, I went through these steps for the first time myself. I had no idea how to do it. I kept asking people on the internet, kept asking Stack Overflow, looking at random guides. And you know what? It's not as daunting as I thought it would be. It's something that I can put into 20 slides, and hopefully when everyone goes home tonight, they'll start thinking of what Java projects can they open source and throw on Maven Central as well. So first, the problem set of what we were trying to solve with this library that we open source. Well, we build Android applications, and building Android applications is a little more complicated than just being on web. Now, Android apps have to have their data be fluid and always available. If a user opens their phone for the first time when they are offline on the subway, they expect to be able to read the New York Times. We get really cranky users if our app doesn't act like a newspaper. It has to have that same experience. Secondly, users don't like their UI experiences blocked. They don't like a screen overlay that says, hold on, I'm loading the data. They don't like their scrolling to be stopped while additional tabs are loading. And finally, users want their apps to be fluid while still minimizing data downloads. So we kind of learned this the hard way. If you download the same article 10 times, users get really upset because international users pay per megabyte. More and more people in the US are actually paying per megabyte now too. And what you really should be doing in mobile is minimizing how much data you are downloading. So Android overall, Android is open source. And for the JavaScript fans, I did 3 equal signs. I was hoping that's the proper number of equal signs for this. And what I mean that it's open source is both the framework is open source, and there's also a ton of libraries that fill all of the gaps that are left by the framework. We don't really have a good network clients in Android, so the nice guys at Square made OKHTTP and retrofit. Threading with async tasks, how kind of the Google way, excuse me, coming off the flu, isn't quite what everyone wants it to be. So Netflix started porting over some reactive stuff from .NET and called it RxJava. Dependency injection also isn't built in the way that some other frameworks like Spring kind of show you how to organize your code. You know, we're kind of left in the dark on Android, so Dagger came, and again, Square brought it out, and now Google is supporting it. And there's other libraries like Butterknife that just kind of help you with eliminating boilerplate and just making your code look really nice. So I'm going to make a big statement now. We're going to add an additional one to this all-star list of Android libraries. And the New York Times wanted to finally bring to be something we call the store. And this is our little middle piece that brings our app together. So for those that want to check it out, we debuted it last week. We're still waiting for our official release, but we started picking up some stars and picking up some pull requests externally, so I might as well share it here. So you might be asking, what is the store? Well, a store is something that will extract away your data operations. By that I mean the fetching of data, the parsing of it, caching it in memory, caching it on disk. And what it does is treat your data in sort of a repository pattern. To me, if I'm a UI developer, I should just be able to say, give me an article. I shouldn't have to say, give me the article if it is in the cache. If it's not, check the second cache. If it's not there, get it from the network. You know, I should have some kind of abstraction for give me this data resource whenever I need it. Secondly, we wanted to do something that'll be configurable. So right now at the New York Times, oh no, typo. My wife usually checks over my slides, so she's right there if anyone wants to yell at her afterwards.
My fault, totally my fault.
So, continuing on. So, the other thing that you need to be cognizant of in Android is that you need something to be configurable. So right now at the New York Times, we have 2 applications. We have our flagship newsreader application, which kind of is a newspaper, and we now have a crosswords app that was recently developed. Those apps are on different teams. One team wants to do flat storage, where they just save to files and just serialize their JSON, while the other team wanted to use SQLite. So if you are going to have a solution for data loading on Android, it needs to be pluggable the way that the network clients like Retrofit are pluggable for any JSON parser, for any data storage solution. And the other thing that we really wanted to do was expose this using RxJava observables. we feel like RxJava started picking up a lot of steam in Android. It solves problems. It lets you combine multiple data sources, lets you subscribe to them, lets you change them from synchronous to asynchronous. And so we wanted to expose all our data operations as RxJava streams. So I'm sure that sounds great to all of you. Everyone's very doe-eyed looking back at me. So how do you actually use this, and how can you make your data flow as easily as we do at the New York Times? The first thing you need to do is add a single dependency, and the second part of my talk, I'll be showing you how to make one of these yourself. So you'll add the Android store dependency. You'll open a store, because that's what you do to stores, right? Someone builds a store, and then someone has their grand opening. And a store only really has one requirement. You need to give it a fetcher. By a fetcher, I mean you need to tell the store, if it does not have the data when someone requests it, well, how is it going to go and get that data? So what you need to do is implement a single interface. You can either implement this in your own class, or you can do what I do here with lambdas, and basically have a delegate that when this store needs to get new data, how is it going to do it? And if you notice, there's actually a barcode being passed in, which think of it as some kind of request parameter or container for you to hold your request in. So now that we have this fetcher, I'll go back one. So the other thing to kind of notice here is that that fetcher needs to return an observable. We realize that even though a lot of Android developers are starting to use APIs that return observables, not everyone does. So in the same manner, you can pass it a non-observable fetcher as well. That'll just return whatever your data is. So if we kind of look at this example, I'm building a store that's going to be managing article assets. It's going to be calling some API, get article, which is going to return that article to it. So that's all we really have at this point. So now back to what that barcode was. So we were passing in a barcode. Think of a barcode as just a request parameter, just some container to say, hey, I'm asking for something or another. And once you make a barcode, you can call on your store some method, in this case fetch, which will then call your fetcher and return whatever the data was that you needed. And the reason that we did this as RxJava, we can kind of see in this slide, with 2 additional lines, a subscribe on and observe on. All of our threading is taken care of. I'm scheduling this to work in the background. I'm getting my results on the main thread without having to do async tasks or having to do my own thread pools or any of the other garbage that I never actually learned how to do myself. So if we look at how this will actually flow, and this kind of goes into that unidirectional data flow aspect that a lot of other frameworks like Redux are going towards, or have gone towards. When your UI wants to request some data, it's going to call your store.fetch. It'll delegate that fetch to a fetcher implementation that you have. Now, the thing that I didn't really tell you about is that it's actually going to cache the data on the way out prior to returning it to the user. So you're never going to be interfacing directly with your fetcher. You're really ever only going to be getting cached data that may be refilled when you called your fetch. So now that we can get new data whenever we want, well, that's not really what every app is going to want to do. This doesn't really go in line with what I was saying of you shouldn't be requesting data more than you need to. So you could also get your cached data and simply calling a different verb on your store, calling get instead of fetch, will now turn this around a little bit, and we're going to keep building on this diagram. Again, shout out to my wife that made all the diagrams. Little round of applause. Awesome. I'll embarrass her all night. I'm glad she came. Yeah. So now when we call store.get, there's a decision point that doesn't exist in fetch. The decision point is our data currently cached in memory? If it is, get will return from cache rather than actually hitting your network. This is really nice. We use this a lot. Most of our calls within our app are get rather than fetch calls. To give you an example, you should really make all your data calls asynchronous within your application. So when our app starts up, we actually call something that is a config store, which has our configuration, from 12 different places asynchronously at the same time. And because there's throttling within the store, only one request will ever hit the network, everyone else waits. Once that cache is filled, it'll return those cache values to everyone. And all of this is completely abstracted away from the UI or from any new developer or intern that starts on our team. All I really have to tell them is find the store you need. Is it an article store? Is it a comment store? And just call get on it. And you should get data if you have it. Now, the other flow that I kind of didn't go through here is, well, if there isn't anything cached in memory, get will work exactly the same way that fetch did. So if you just want data and don't really care if it's old or not, you can call get rather than fetch.
Why would you ever use fetch?
So why would you ever use fetch?
Force a refresh?
Yes, so we use fetch when someone does a pull to refresh to make sure that when they're doing a pull to refresh, it's actually hitting the network. And we also use fetch for our overnight updates. So times that we actually want to go to the network and make sure we're caching the data, say it actually happens in our app at 5 a.m., so by the time everyone gets on the subway, they definitely have it. Those are the fetch calls. But yeah, you're absolutely right. For the most part, you should really only be calling get, letting the store decide, does it have the data, or does it need to call through to your fetch? Good question.
Well, wait a minute. How do you handle follow-up? That's when you know you need to fetch. How do you handle expired data?
So we
How do
actually,
you set the more important problem is how do you set the expiry?
that's a great question. So we leverage Guava caches, and when you are building up a store, you can also pass in a cache configuration. We have a default one where we'll cache 100 items in each store, but if you want to have a write access or a last read or any other caching policies or a size caching policy, you can configure a store to have those policies as well. So any
Not my question though. You said when you create an object and you export the object from the server, presumptively there's a policy on when it would have to be refreshed.
So this does not deal with cache control at all. If you're talking about cache control headers that the server is presenting to you, that should be handled within your network clients and not at this layer. This is a wrapper to data calls that may or may not necessarily have their own caching policies that are at the HTTP layer. Okay. Thank you for the question. So kind of moving on, the next thing that a lot of Android data flows need is some way to parse your data, right? You don't really get JSON that you're going to be displaying on your screen. You get JSON that you need to mutate and inflate into objects, and probably use JSON to get into the final form that you're going to need. So in a similar way that you can pass in a fetcher, you can also pass in a parser implementation. And the only thing that changes when you're passing in the parser is that rather than having a store builder, so remember the store builder only has one generic for what it's going to be returning. If you're going to be parsing something, you're kind of going to need two generics, right? You need to know what your raw type is that's coming from the network, and you also need to know what your final object is that you're going to be returning to your UI. So your raw and your parse type. So here, instead of using a store builder, you just change the class to parsing store builder. You pass in a parser. The parser looks a little sloppy here just because you have to wrap it in a try catch since JSON is strange like that. And looking at this, it gets a little more complicated, but not too bad. The important thing to notice is that the parsing happens between fetching from the network and saving it to the memory cache. The reason that this is important is to keep heavy or long-running operations to a minimal. If your parsing step is really expensive, there's no reason to be parsing the same data over and over again if you're not fetching it from the if you're not fetching any new response from the network. So what the memory cache does is actually save the final representation of your parsed objects in the store for the next call to get. And going back to what we looked at here, this parser looked really crappy. So we didn't want to put this into all of the code, so we made little middleware packages, very similar to Redux, that something that looked like this before can just be a one-liner like this. Parsing code is generic. For the most part, you're calling JSON, so why have to implement this? You could instead use our JSON source parser, as long as you're using a network client that can return a buffered source, which OKHTTP and Retrofit both can. You can use this built-in parser and save yourself the headache of having to implement this over and over again. And the final piece is disk caching. So sometimes memory caching isn't enough for Android. So I can cache something in memory so that when I rotate, it's still available in some kind of singleton or in my store. But that doesn't help me if my app gets backgrounded for, say, 8 hours and users use some other app, memory got reclaimed, and now when they try to use my app again, they don't have network and nothing is in that memory cache. So the other thing that you can do is do a second level of caching, which we kind of call persistent caching or a persister. And you can do this in one of two ways. You can either implement this yourself. So this is what I was kind of getting at before, that if you're using SQLite for your storage, fine, you can write and read your object from SQLite. If you're using flat storage, that totally works as well. Our only requirement is that you should give us an observable coming off of your disk storage, because we want to keep the same type coming from network as we do from disk. And this is the most complicated of the pictures. The only large thing, or the only important thing that I really want to show in this as well, is that the parser sits in front of the disk. So again, we're going to go through this whole unidirectional flow, right? In the worst case, you're going to go to your network. When you go to the network, you can stream your bytes directly to disk. From disk, you'll then be able to stream your bytes to the parser. Once that object is inflated by the parser, you can save it to your cache, and once you have it in your memory cache, boom, the user can get it. And the nice part about doing it this way is that if you have multiple requests coming in, like I said before, you can throttle them at every level. That if you have 3 things asking for it in memory and you don't have it yet in memory, there's no reason for all 3 to go to disk or them all to go to the network. The rest of the requests will wait until that one response comes back, and you will broadcast it to all of them. And same thing as the persistor, I don't like implementing a lot of code, so we have a source persistor built in as well. So this is how we work with data at the New York Times. This is how we keep networking code outside of our activities, and usually within our presenters or within our business managers, whatever we want to actually access our data. We spin up a store for every one of our endpoints. All we really have to implement is a fetcher, and then we have 2 levels of caching, and our app works offline brilliantly. So I hope that you get something out of this library as well. We'd love to get some contributions back to it. And yeah, that's what we did. And now I'm kind of going to talk about how I got to this in the last 2 weeks. So the last 2 weeks of my job was trying to get, we had this library and we had this code, and now we know that we want it to be open source. And how does that actually happen? So I kind of see it as a few different parts. You need to get it on GitHub somehow, and you need to get it onto somewhere where developers can pull it down. So basically like NPM or something. You need to get it on Maven Central so that anyone using Gradle or using Maven will be able to pull down your project. So I'm going to start off really slow with the first steps that you have to do, and then we'll start ramping up to things that I hope a lot of people in this room have not done. Before I kind of start, has anyone actually open sourced anything in Java here? Has anyone gotten anything up to Maven Central? Perfect. This is the perfect crowd. Everyone's going to go home and do this. It's super easy. So the first thing you need to do is create an Android project, right? You have code. It's in your actual big code base at your work, and now you want, or it's in some other project. You have tidbits that you keep moving from one project to another. This might be just some static utility class that you thought the rest of us would want to use. Maybe just like some num adder that I would love for you to open source. So after you create a project, normally Android projects have an APK. They have an app. They generate something that's going to go on the phone. And when you make a new project, it's actually going to make an app module there for you so that you can start putting activities and actually start building an APK. Well, that's not what you really want to do when you're open sourcing a library. What you want to do instead is add another module, which is a library module. A library module will then become an AAR rather than an APK. And AARs are kind of like jars. They're Android archives. Next, not really going to show you how to do this part. Y'all know how to add code. You're going to add some code to your library, because without it, you're not really going to have a library. Yeah. And FYI, like Google Slides for the first time had these like cool auto-suggested templates on my thing. So you'll see some fun slides in here. And now that you created the project, and I'm going to be doing this. See, I'm doing this talk. Anyone can do this. I don't care how old you are. I don't care how much experience you have doing Android. And full disclosure, I don't know how to use Git from the command line. I can only do it through Android Studio, and I was able to do this. So I go to menus and find menus like this that say Share Project on GitHub, so I don't have to know how to mirror my local or create it or do anything else. And this works brilliantly. This will actually create a repo. It'll ask you for your GitHub credentials, and everything will get you closer to where you need to be. So next, you have a repo. It's on GitHub. What do you need to do? Well, you need to create a README. I'm assuming someone's going to want to go to your project at some point, and they're really going to want to know what it does. Some suggestions for things you should talk about is who's the project for, why did you create it, what does it do, and how does it do it. Nothing too crazy, but if you know Markdown, it'd be really nice to actually style this and make it look all pretty like other ones. I'm terrible at Markdown myself. We didn't really go through that too well. Besides adding a README, and this is something I learned new this week. So I know that projects have licenses, right? You have to add a license. You should probably add it to your GitHub. I believe GitHub actually has a default license, but you should really be adding it to your project. And what I did is I was like, all right, all these things have something called a license file. I believe it's a license.md. And what I did is I went to my repo. This is the store repo. I created a new file, and as soon as I started typing license, this really nice dropdown appeared out of nowhere, just out of the blue. I love the GitHub people. And what it gave me is a choice of common licenses that I can add to my project. So you don't even need to know how to create these licenses or what they are. I mean, you should probably know what they are. But we used Apache 2 at work, and that seems to be a standard one, and MIT when you're open sourcing stuff. So now that we have a GitHub repo, and we have a license, and we have a README, we need to actually get this somewhere so that people can use this in their project. I don't really want to use Jetpack. Some people use that, but it's a little weird that you have to add additional dependencies. And I feel like most people aren't just going to download your project and compile it themselves and move the AAR into it. It's got to be convenient. It has to work through Gradle, and it needs to be on Maven Central. So even though Maven Central is really cool and super advanced, their process for uploading something, in my mind, is quite comical. So I needed to get something on Maven Central. I always think of this as this abstract giant thing that hosts all the repositories and works flawlessly. I've never seen it go down. I was like, they must have pretty cool tooling to get this to all work together. Well, to get something on Maven, if you don't have an account, what you need to do is go to Sonatype, that's the company that runs Maven Central, and open a Jira ticket asking them to allow you to post something on Maven Central. So first you go, just like your company's Jira, you create an account. Here's our New York Times one that I created. And you guys can see my strange description. I had no idea what to write besides New York Times team wants to open source some stuff. Please, I guess. And once you open this ticket, 2 days later, Maven gives you a reply like this. And it is actually a human that goes in, is what it seems, and like, I don't know, faxes something somewhere to Antarctica, and suddenly you get access to Maven. So once this happens, the username and password that you created for Jira is actually going to be your username and password that you can deploy to Maven Central with, that you'll be able to deploy your artifacts with. And they actually tell you all the different repositories that you can deploy it to. I had no idea what these repositories are or what to do with them, and luckily there's plugins for Gradle that abstract away all of this. So next step. I started going through some instructions. They had instructions on their website of how to upload all this. I was doing fine until I got to a step that showed me a Gradle properties, and there was something in there called a GPG key, and I had no idea what it was. Well, one of the nice advantages of this antiquated Maven Central process is that there's a human and a Jira ticket, and you can bother them. And that's exactly what I did. Asked them what I need to do, where do I get the signing key ID, password, key ring, they didn't give it to me, and the nice fellas pointed me towards a document that shows me how to generate it. Yeah, I was literally flying blind. I've never done any of this, I have no idea what any of this means, but just kept chugging along, and so far so good. So all right, I went to their site, this was the site. It seems like I had to run a single command. I installed with homebrewed GPG, brew install GPG. I can use homebrew, that's the one command line thing that I've learned. And I generated a key. Once I generated this key, followed these instructions, it actually generates both a key. It asks you to give them a username and password for your key. I think that's what that key ID and password is. And when it generates it, it actually will generate a keyring file, I believe it's called. And that's what actually will go into your Gradle properties of how you're going to be uploading. So you're not just uploading using a username and password. You're actually giving them the location of some file on your computer that is going to be used for whatever this deployer script is. I thought that was kind of novel, but also a pain if you ever want to do this for multiple machines. Okay, so that's the next screen. So now we go back to our project, right? We have this Android project. We've created this library module. We've added all of our amazing code to it. And now we need to start configuring it so that we can actually deploy it to Maven Central. So what I did was went to my top level Gradle properties, and I added the following configurations. And that's where that Sonatype username and password is that Sonatype Jira account. I had all my signing, keys, password, and keyring file locally in my machine, so I was able to put those in as well. And I also added a version name, code, and group for whatever this was. So our group was com NY times Android, and our version was 1.0 since this was that first release. Just something of note, don't do what I did. Do not check this into GitHub, because if you check this into GitHub, everyone gets your credentials. So then I had to walk over to someone in the company that actually knows how to use Git to show me how to revert my, my commits so that everyone doesn't have my keys. Pretty sure I did that right. Yeah. So for my mistakes, you all will learn. All right, so we updated our top-level Gradle properties. We added it to our git ignore so that it won't get checked into GitHub. And we'll also go into that module. So in my case, the one module I was trying to upload with was called cache. And you have to add a few Gradle properties here as well. These are Gradle properties that you can check into GitHub. There's nothing sensitive here. So this basically tells Maven what the artifact is going to be called when people are going to be downloading it. So remember when in that first slide we had com ny times Android :store. This would be com ny times Android :cache with whatever version it is. So if you have multiple modules within your project that you want to upload, so say you wanted to split a single project into multiple libraries, this is really easy to do it this way, and all of the uploading stuff that I'll show you after this will work even if you have multiple modules. It will upload all of them as long as each module has these POM settings and is a library project. So next I went to my top level build.gradle file. Remember we got a build.gradle at the top of our project and one for each module. And I added some additional metadata that a plugin that we're going to be using is going to be pulling. So I'm going to be using Gradle. Gradle is the default build system in Android. But Maven repositories is where this archive is actually going to be hosted. Gradle is able to pull from Maven repositories, but Maven artifacts have to have something called a POM file that has descriptors of what dependencies exist here and everything else. You can hand code it, or you can just add these few strings to your build.gradle, add a apply from Maven push Gradle script. You can copy the script from my project. I copied it from some other project on the internet. And this actually adds all of the Gradle tasks for you to be able to deploy and makes that POM file and packages everything together. And finally, you run your upload archives, well, not finally. Well, finally for this slide, you run your upload archives task, which will build everything and put any of your library modules up on a staging repository that you'll then be able to confirm. So let's take a look at what that looks like. They don't want you just to be able to deploy something to live every time you press a button in your IDE. I would be screwing that up a lot. So there's another little intervention step of something you have to manually do prior to it being in the real world. So what you need to do is, and this again, I was really surprised that this is a step. You need to go, so has anyone ever used Nexus in the past? Perfect. So yeah, for those of you that haven't, Nexus is just something that can host Maven repositories. A lot of companies use them internally, but Sonatype also uses Nexus to manage their Maven Central and all of the staging repositories. So what you need to do is go to that URL that I have on the bottom. You can log in with those same credentials that you logged into Jira. And here you will navigate. I'm so sorry that the slide's a little small. But you'll navigate to staging repositories, search for whatever your group was, and when you do that, you'll see a temporary repository that was made for whatever you just pushed. And what I like to do in this step, or what you should be doing in this step, is so you can go to the content to see what you just uploaded. If you uploaded multiple artifacts, they'll all be here, and you can actually see what the files was. Something that I kept having trouble because I was uploading multiple was that the POM files had the wrong names in them. I did store, not stores, and vice versa, and nothing was working correctly. So what you can actually do is look at the POM file that's generated, look at what ARs and jars are generated, make sure that everything is the right version that you need. And once everything looks correct, you will click close. Weird, right? I thought so. So if everything is right, instead of confirming something, you click close. And if you click close, the screen, none of the other buttons appear. What you need to do next is refresh this, and then refresh it again, and sometimes refresh it a third time. And when you refresh it the third time, that release button will start being enabled. It will never be enabled before you close it, so you basically have to close the staging repo before they'll let you deploy it. And then you would press that release button. When you do that, about 10 minutes later, your artifacts are going to be live on Maven Central. You can go search.maven.org and actually look them up there, and they're in the wild. And I believe there's no way to actually take them down if you screw something up, so be careful with this last step. It's sort of permanent. And now, something else that they asked you to do is so when you deployed your first artifact, they have to do some kind of syncing. I think they just don't trust you the first time. I want to make sure that they check it. So what you need to do is go back to your Jira ticket and leave them something that says like this. Okay, I pressed the close and the release button. Everything worked great. And then they flip a magical big switch on their side. And you only have to do this the first time, and then everything is in the wild and everything will work correctly. They gave it the warning it'll be up to 2 hours. It usually takes about 10 to 15 minutes from what I've seen. So that's how you get something onto Maven. And I'm telling you, it's pretty easy. It's a little strange, but yeah, it's not too bad. What makes it really easy is that those Maven deployer scripts exist, and they've been refined by other companies, and they work flawlessly. And I was really surprised that when I hit that Upload Archives button, if I had all those properties correctly, it all just works. You get some logs, and everything goes up to Maven Central. So now you have your project. You're on Maven Central, and all these people are starting to use it. And they think your project is the greatest thing ever, and now they want to start opening pull requests to you. And at first, what I started doing was asking every person, did you run the test? And that felt really awkward because there's like 50 people watching this repo getting my email every time, did you run the test? So what you should really be doing is some kind of continuous integration. And this was another step that I've never actually used Travis. I had no familiarity with it. We use Jenkins at work, and we have like a guy that's a genius that gets Jenkins to work, and Travis doesn't take any of that. So to set up Travis to run your test on your repo, what you need to do is go to Travis's website. You log in with your GitHub account. It shows you a list of all of your GitHub repos. You like click on enable or click, I can't remember what the button was on it. I couldn't reproduce the step. You choose which repo it is, and it does all of the hooks with GitHub so that on pull requests things will work. You still just need to add one additional file, and I was actually really blown away with this as well. I copied this from somewhere else, from just like some random project, and actually didn't have to change anything. By adding this Travis YML to your GitHub's top level, every pull request will now run whatever is in this script. So I'm writing my Gradle W check task, which is what runs my test. What's really neat about this to me is that all of the platform tools and everything else that you need for Android that normally we have to like log in the Jenkins and manually install with the SDK installer, this just all works. The Travis people figured it out better than I could. Yeah, that was. So now that people are contributing and it's starting to open pull requests, they look terrible and they're mostly changing your code styles. You don't want them to do that. So you should probably add a contributing markdown file as well. The contributing file is how you want people to obviously contribute back to your project. And what's nice about this is that if you have it named what I have it named here, anytime someone opens a pull request, they'll get a little pop-up that'll say, read the contribution guidelines linking back to this. So it's a nice reminder for people to like, if you have some kind of notes, if you have some kind of templates, if you want to run certain tasks or not touch certain parts of code, this is where you would tell the external world what they should be doing. And the final step is submit a talk to the GDG. So you can get up here and the way that I did, talk about this new awesome library that you made and tell everyone how much fun they're going to have using it. And that's it. Thanks for listening, guys.